In the atmosphere, carbon dioxide is a potent greenhouse gas. However, in the soil, it restores and nourishes. And that's why some researchers see soil carbon sequestration as a possible magic bullet in the fight against climate change. Joining us now to explain in Bethlehem, Pennsylvania, Chris Nichols, Chief Scientist at the Rodale Institute. In Columbus, Ohio, Ratan Lal, Director of the Carbon Management and Sequestration Center at The Ohio State University. And here in our studio, Ellen Schwartzel, Deputy Commissioner in the Office of Environmental Commissioner of Ontario. And it's good to have all three of you on our program tonight. The official launch for the initiative dealing with this is called the 4 per meal initiative. That is not a typo. It's not 4%, it's 4 per meal. And it took place at the Paris Climate Conference. And to help explain what this is all about, soils for food security and climate, we got a little video here we want to show. The Center for Food Safety put this together. So we'll play this clip and then we'll come back and chat. Roll tape, please.
Plants capture carbon dioxide in their leaves and pump the carbon down through their roots to feed hungry microorganisms living in the soil. Now, what had been atmospheric carbon, a problem, becomes soil carbon, a solution. Practices like keeping soil covered with plants, increasing crop diversity, composting, and carefully planned grazing are proven ways to put carbon back into the soil. The French government recognizes this and is calling on all countries to join them in increasing soil carbon by 0.4% each year. If every nation were to reach this ambitious but achievable goal, we could store 75% of global annual greenhouse gas emissions, enough to make a real difference to our planet's future well-being.
Chris, let me start with you on this. If we need to put carbon back into the soil, that suggests perhaps that the soil is depleted from carbon or there's not enough in it to begin with. So let's start there. How has our soil become so carbon depleted?
Agriculture has been a big part of depleting the carbon in our soil. What has happened when we do tillage to our soil is we expose organic matter, the carbon that's in our soil, to the surface and to hungry microorganisms that will rapidly decompose it and break it down back into CO2 and release that long-term stored carbon as CO2 back up into the atmosphere. In addition, other farming practices that we do, focusing on monoculture crop production as well as not utilizing cover crops, is limiting the amount of carbon that we can actually put back into the soil and feed the organisms that will actually convert that carbon into forms that are going to stabilize it for a longer period of time. So we need to look at the plants as being the biggest mechanism to be able to draw that CO2 back into the soil, and then couple that with practices that are going to make sure that that carbon's going to stay in the soil and it's going to be fed to all of those hungry microorganisms that can stabilize it.
Ratan, let me follow up with you on that. Why do you think that farming practices haven't adapted to address the degradation of agricultural soil?
Well, historically, plowing has been the method of seedbed preparation, and therefore plowing exacerbates the problem of erosion and decomposition. Until the conservation agriculture systems are developed, plowing and mulch farming had been very difficult to practice. Also, the question of realizing that soils have been a source of atmospheric CO2 was really understood until about 1990s. So now we have understood that the soil have a sink capacity because of historic depletion, and we can indeed sequester carbon dioxide as organic matter. I think that's a clarification I'd like to make, that CO2 in soil is sequestered as soil organic matter and not as a CO2 gas. CO2 gas in soil will not stay. It's the conversion of CO2 from the atmosphere into plant biomass and conversion of plant biomass into soil organic matter that we are talking about sequestration. So now we have improved practices that we have tested, verified and validated, and we can recommend them that they can be adopted for reversing the trend, taking carbon dioxide from the atmosphere back into the soil.
Ellen, let me bring you in at this point. Are you a fan of trying to put carbon back into the soil?
Absolutely. Our office has been talking about soil health in Ontario since about 2008, 2009, and soil health, of course, is something that everybody would like to buy into. But we've been more specific in more recent years, saying that really Ontario soils could be a terrific asset in dealing with the climate change battle that we have.
Well, let me see if I can understand that better. Was the initial initiative to just try to improve the soil itself, or was it with a view to improving the whole climate change issue?
Well, I would say that our own thrust and emphasis was first to say let's as a province focus on our agricultural soils and the health of them for a whole host of reasons. But secondarily, we're realizing that we can actually use soils, agricultural soils in Ontario, as a sponge essentially for carbon. Yeah.
I gather they have been doing something like this in the province of Alberta in Western Canada for nearly a decade now. And here are what the province says are some of the benefits that have accrued to Alberta as a result. From 2007 to 2012, the agricultural offsets in Alberta include voluntarily reduced carbon levels as much as taking 2 million cars off the road. It represents 1 in 3 tons of reductions by regulated emitters, and has generated close to $132 million for farmers and aggregators. So Chris, let me get you in here at this point. $132 million bucks. I mean, that's real money, obviously, but is it enough to cover the costs of changing the way that a person farms, or taking care of all the paperwork that they need to document, all of that kind of stuff?
Well, I think that's a very good question. And I think for farmers, what we're seeing and what Ellen alluded to, as well as what Dr. Lal alluded to, is the fact that we're seeing benefits that come with putting organic matter back into the soil. That is not just helping with the health of the soil, but it's also helping with the productivity of our agricultural systems and allowing those systems to function under climatic uncertainty. We're in an era in which we're seeing prolonged drought periods, we're seeing very heavy rainfalls, and so the soil has, with the organic matter that's in that, has the ability to become much more resilient and withstand a lot of that variability. And so what you see happening is that farmers are still able to continue to produce and provide for their income that they need to have by adopting these regenerative organic methodologies, so reducing the amount of tillage that they have. And again, as Dr. Lal was kind of talking about, this needs to be focused on organic matter that we're putting into the soils. And we need to have a living plant in order to be able to do that, because that plant is going to capture the CO2 and convert it into the compounds that are then going to be able to build up organic matter in the soil and feed those microorganisms.
Understood. Ellen, you wanted to follow up?
And just to reinforce what Chris said, our office a couple of years ago highlighted a few case studies of Ontario farmers who have worked, with standard commodity crops in Ontario, that's corn and soybeans, and have done not only no-till approaches, but have experimented and really tried to maximize their soil health, and are producing really good yields, way above average, and are really pleased to see that they're getting through droughts better than their neighbors, seeing less nutrient runoff, and so really reaping the benefits, and that being keen observers, they realize that they want to continue doing that.
Putting the carbon, though, back into the soil seems to be working well for the province of Alberta. Do we have the kind of soil in Ontario which could similarly benefit?
Well, what we have heard from the Ministry of Agriculture, Food and Rural Affairs is that Ontario's soils, by and large, are a bit wetter than what you would have in Alberta, and that means that it may be a little bit more challenging. Also, our soils are more diverse. We have many different types of soils. But we would answer to that you just need to get out there and do the research. We have great research institutions in Ontario. We need to to actually document, to have those long-term studies in Ontario, the launch and learn approach on figuring out what it is that best brings the organic matter back into the diverse Ontario soils.
And let me do one more follow-up with you. You know, of course, the Ontario government's setting up this cap and trade system now.
Yes, sure.
Does soil carbon sequestration fit into that new cap and trade model that they want to set up?
It does indeed, yes.
How so?
So that it's a brand new world that we have here, because until about November of 2015, there was no real possibility of a revenue stream that could be used to promote this. But with the cap and trade program, as they are designing it now, they have begun talking about certain kinds of offset opportunities. And in their long laundry list of things that they want to examine, they include conservation tillage, they include grasslands. So right there, that's where they really need to get those protocols in place in Ontario that will reassure the people who are, selling and trading offsets that this is a verifiable and long-term way to sequester the carbon.
Okay. Rattan Lal, I'm going to get you back in here, and once again referring to this French initiative, the 4 per meal or 0.4% initiative that came out of the French Ministry of Agriculture. It is a voluntary program. And of course, there's a great debate out there as to whether or not voluntary programs work or whether you need something that's far stricter. What's your view on whether or not a voluntary program to do this will be effective?
I think voluntary program will be effective only if the farmers think that it is beneficial to them through carbon trading or through increase in productivity or erosion control or whatever benefit they can get. If the farmers do not see the benefits, then the voluntary system may not work. And I think one way we can make it work is either through cap and trade, carbon farming, or through payment for ecosystem services. And it should be done at a fair price. And I think the fair price is not 20 euro, which is at the moment in Europe, or much less, for example, in North America. It has to be a very fair price at a transparent system of payment to farmers. I would like to also mention about the documentary statement, 75% offsetting. I think that's probably a little bit overambitious. I think the maximum carbon we can put in the soil, which is cropland soil of the world, if we can implement on a global scale, is about 1 gigaton. And that's about 10% of the total emission by fossil fuel combustion at that time. So even though that small percent, 10% say for example, but the co-benefits are many. And I think even this small incremental increase is very important because of that co-benefits. Most important being food security, water quality, biodiversity, perhaps climate change, impact and improvement of the value of the soil. So there are many other benefits. So even if it's an incremental increase which is small, I would still think this is a very important initiative.
An important initiative, but that's quite a far... Well, what you've just said is really different from what the folks in France are saying. And Chris, let me get your take on that. We're hearing some projections that 75% of what's causing climate change could be improved if this initiative goes forward. Rattan Lal's just said it's more likely 10%. That's a pretty vast gulf. Where are you on that?
Well, I think there's a couple of things to clarify. I mean, what Dr. Lal was referring to is the fact that about 10% of the carbon could be sequestered in the soil and offset 10% of the emissions that we have. And he can correct me if I'm speaking out of turn, but I think that it's more of that looking at an offset type of thing. And I disagree a little bit. I think that there's some potential to be able to do that more. And he's also talking about in agricultural cropland, and there's a strong potential to sequester carbon as well in grazing lands. And so the way that we manage grazing lands, and grazing lands are a far larger landscape of the global environment. So there's a lot more land space that could be utilized better under grazing management to help to sequester carbon. So I think there's a couple of things to clarify with that. The other thing is that what would, by changing some of these management strategies, when we're looking at these regenerative organic types of management strategies, as I said, we're going to reduce the amount of inputs that we need to have in the system. And so what that does is that reduces the emissions that come from the creation of both synthetic fertilizers and synthetic pesticides. It also helps to reduce the amount of nitrous oxide emissions from the soil. And nitrous oxide is about 300 times more powerful than CO2 as a greenhouse gas. And when you have an overabundance, which oftentimes happens with the use of synthetic nitrate fertilizers, you have an overabundance of nitrate in the soil, and when you don't have good organic matter and good soil structure to help to manage water well, you can get some saturated conditions that are going to increase the amount of nitrous oxide emissions from those soils. So by improving the agricultural techniques that we're using, we're going to reduce the amount of nitrous oxide emissions from our soils. We're also going to be reducing the amount of CO2 emissions from our soils, as Dr. Lal talked about, that we've seen in the 1990s started to have that as a measurable, significantly measurable quantity that we've looked at, that soils are responsible for some of the CO2 that's in our atmosphere. By reducing the amount of tillage that we're doing and utilizing conservation agricultural practices and reducing the amount of monocultures that we have, that's going to reduce some of that carbon evolution from the soil, which is going to be beneficial as well.
Okay, a lot to unpack there for a second,
I think
Chris,
there's many things.
But Ellen, let me try this though. I really still need to get a better understanding of whether or not this is the magic bullet that the proponents say it will be, talking about reductions of 75%. Versus what Ratan Lal says, which is more like 10%. Where are you on that?
Do you know, I think even if we focus on the low end of that scale and we say that, you know, conceivably agricultural soils could mop up, you know, with their organic structure about 10%. That would be terrific.
Still worth doing.
I couldn't name you really another magic bullet that we have in Ontario that would be comparable to that. So definitely worth doing. I mean, we know that what we've done in Ontario so far, and you know that Ontario has got its own greenhouse gas emission reduction targets, and we've met our first for 2014, and that was good on us, and we did it because we closed the coal-fired power plants. And we haven't got another silver bullet in Ontario that we can point to. And the hope is that the cap and trade program that is now going to be brought in is going to trigger a whole host of beneficial changes, and this would be one of them, this offset approach for agriculture.
Was there something else that you wanted to
well,
follow up on what Chris said?
Well, I wanted to touch on what Chris mentioned, nitrous oxides, and of course what we've got the phosphorus problem in Ontario. We've got Lake Erie, which has had, you know, horrendous algal blooms in recent years, and that's largely as a result of agricultural runoff into Lake Erie. And so the ministry knows, the scientists know, the farmers know that you need to improve the organic soil structure so that you get less erosion and you can reduce that phosphorus runoff. So that's another co-benefit that it's all connected. The stuff is all connected.
It's all connected, okay. Yeah. But Ratan Lal, who stands to lose if farmers adopt the kinds of practices and put more carbon back into the soil that we're talking about here?
I think nobody stands to lose. It's really a win-win situation. And I, again, want to go back to the question, we really should not be hung up on the numbers, whether it's a 10% or 15% or whatever. I think the fact that the concept is an excellent one, that we want to restore the carbon in the soil where it can benefit many things. And that's an important one. I think the farmers will not lose because their productivity improved, the soil quality is improved, the soil functionality. In fact, if I were a farmer, the value of the land goes up. Algal bloom issue is a real one, and it comes because of the runoff of the nutrients, especially phosphorus and nutrients other than potassium, nitrogen as well, which goes into the water. And these practices, conservation agriculture, cover cropping, mulch farming, controlled grazing, good forages, they will all reduce the risks of soil erosion. And therefore that problem of water pollution also becomes less. I think if cap and trade works, or if the ecosystem services payment work for small landholders, that's another income stream for the farmers. And it's a very important income stream. I think we should not forget about it. I think I want to also mention, in addition to food security, which is linked with the issue, nutritional security. We have almost 2 billion people who suffer from hidden hunger, micronutrient deficiency, etc. Improvement in soil quality will also improve the nutritional security. So the benefits that we get from here are a lot more that we should not really pay attention to whether we can offset 10% or 50%, 75%. I think even if we get 10%, as the Commissioner said, we are really very fortunate because it has numerous other, it improves our land quality. It restores the carbon in the biosphere, which we have lost. And that's the strategy which I'm focused on. And this is a very important step.
Now, I hear you, but Chris Nichols, follow up on this angle. Ratan Lal says it's a win-win-win for everybody involved. Do you think the chemical fertilizer manufacturers are going to consider this a win-win-win for everybody involved?
There are a few people who are not going to necessarily consider it a win-win-win, but I think that even among the chemical manufacturing companies and among companies like Monsanto that is involved in crop breeding and GMO technology, and the new join between DuPont and Dow, from a chemical side, I think that those companies are also starting to realize that there are some other areas in which they could make it a win-win-win situation. Monsanto recognizes the value of soil health and recently bought a company to focus on soil health that does some soil health evaluations and discussions on soil health. So they're realizing that things need to change, and things always need to change and evolve to keep things moving forward. And I think that there's a tremendous opportunity for many of these companies to be able to focus on some other things. There's a lot that could be done with breeding of various types of cover crops to fit in with many of these ecosystems and to provide the ecosystem services that are beneficial for the agricultural production as well as the environment. So being able to do that and getting crops that are suited to areas in Ontario are going to be different than crops that are suited to areas in Alberta and across Canada as well as the United States and globally. So there's a tremendous amount of potential to invest in those areas of research. And also in areas of research focusing, I'm a soil microbiologist by training, and one of the things that Ellen had alluded to in talking about phosphorus, getting a better understanding of how nutrients are processed in the soil. We talk about phosphorus deficiency, but really what it is it's an available phosphorus deficiency. And there are a number of bacteria that help to solubilize phosphorus that is highly unavailable in the soil. And so when we do soil testing and when we do soil measurements for nutrient content, we're measuring at that point in time what is directly available to the plant without any other type of biological activity. And when we are feeding the soil microbes from the carbon in the atmosphere, from that CO2 through the plant, that feeds those soil microbes that then can process those nutrients into a plant available form when the plants need them.
We're down to our last minute. Ellen, let me give it to you. How does Ontario hop on board this idea?
Well, we've been saying for a few years now that Ontario needs to launch and learn, and we're glad that the cap and trade program now at least has got this notional idea that they're going to work on protocols. We know that the Ontario Federation of Agriculture is behind this and says, yes, absolutely, a new revenue stream for farmers. What could be wrong with that? Develop those protocols. And protocols, that means really that it's got to be verifiable, it's got to be measurable, right? And this concept of permanence is important. But let's experiment. Let's launch this. Let's go.
Starting now.
Now.
Gotcha. Can I thank all of you for joining us on TVO tonight? Chris Nichols, the Chief Scientist at the Rodale Institute. Ratan Lal, Professor at School of Environment and Natural Resources at The Ohio State University. Ellen Schwartzel, the Deputy Commissioner in the Office of the Environmental Commissioner of Ontario. Thanks, everyone.
Thank you.
Thank you.
Help TVO create a better world through the power of learning. Visit supporttvo.org and make a tax-deductible donation today.